So it's a good afternoon and welcome. This afternoon session, Introduction to Time Series Forecasting. My name is Peter Myers. I'm very happy to be here to present this topic, one of my favorite data mining topics, and especially a good one if you're new to data mining. Here's an algorithm that you might find quite useful, that has a more gentler learning curve, I think, in certain situations. So welcome. For those that are watching this on streaming, I'm standing here before this major auditorium, and I think I have a head count of about 30 or 40 people, and that tells me there must be a Power Query deep dive session going on. Okay, so I appreciate you guys have made the time and effort to come here, and I think it'll be well worth your time to see what I've got to say. Please take this opportunity to silence your cell phones. The next 60 minutes, here I am, Peter Myers, as a BI expert, to share with you some experience around the time series algorithm and how we can use it to perform forecasting. The outline will be to describe the data mining process. We're going to treat this with the idea that you have absolutely no background in data mining. We're then going to introduce and focus on one of the data mining algorithms, one of the 9 available with SQL Server. And I'm going to show you a numerous set of demonstrations that we'll go through using different tools and techniques to forecast from data. We'll talk about algorithm parameters and how they can be used to tune and improve the reliability of your model. And then we'll talk about some business scenarios to get you thinking about how you could use these techniques back with your own data. I think a great place to start then is to think about the history of forecasting, and I mean way, way back. Cavemen. I'll let this sink in for a minute. One of my favorite cartoon authors from Melbourne kindly gave me permission to share this, and it gave me a chuckle when I first saw it. So 2 cavemen pondering the ramifications of producing something well into the future. So it started with the beginning of time. Prehistoric men were curious or had a certain need to understand what could be. What about this? Fortune tellers, tea leaves. I mean, I think it's well known that a certain president of France relied on a fortune teller to help understand what the war strategy should be. Crazy, yes. What about this one? Crazy. The modern day approach to prediction could well be mollusks. All right, that if you feed them the right way, with reliability and freakily reliable. 100% accurate, worked out the World Cup. Is this an appropriate way to perform forecasting or any type of prediction in your environment? Do you think your manager would approve of having an aquarium set up and truck in some octopi? Maybe not. If you think this is appropriate, I'd suggest it should be another session that you're in, and probably most likely another conference altogether. All right, you're not likely to find these topics here. We're here to talk about a scientific approach when it comes to forecasting. This is time series forecasting, which is the development of a data mining model to predict future values based on previously observed values. This is the focus of this 60 minutes. Let's begin with the very basics. Show of hands, has anyone worked with data mining before? Okay, about half of you. Inverse sometimes helps. Who has not worked with data mining before? You're here, you're curious, you're evaluating what you can do. There's the other half. Let's start with a very basic, high-level understanding of what happens when we produce a data mining solution. We start with the design. That has us defining a model that involves the selection of an algorithm that performs a particular task, inputs where data is passed through. An engine then is going to sift through the incoming data to detect patterns that describe that data, and these patterns will then be stored in the model. So essentially this is a container for content. Like the database is a container of tables that contains rows. In the data mining world, a model is a container for patterns. They're stored and they then become a queryable resource. So that's the process that we've just discussed, training data and carefully prepared training data. And in the context of forecasting, this is your observed values across time. The data mining engine hopefully will detect some type of pattern, some type of trend. The result will be stored. And then when it comes time to forecast, you will query this model. It's possible that you could use additional data, and via the engine, the output would be future steps as a prediction. So perhaps far more scientific than an octopus, and certainly far more scientific than relying on the gut instinct, which we'll find that we generally do perhaps a little too often. Now, a word of warning here is that forecasting is not an absolute science. If it was, we'd all be rich on the stock exchange. Okay, funny story was that when I first presented this session, it was at the Past Summit 2009, and I sort of wanted to know that if you put a crazy session title in, would it get selected? And so I submitted one called How to Get Rich Quickly with the time series algorithm, and to my surprise, or half surprise, it got selected. Okay, so I have somewhat renamed it, but it's very much the same content with a more contemporary set of data. Okay. So, with that brief background, you're going to see me demonstrate this in a number of ways using different tools, different techniques. With a focus on just one of the 9 algorithms that are available with SQL Server Analysis Services, it's the time series algorithm. So the big picture is that you will need to install Analysis Services. It has 2 components. Most people know it for the data modeling component, the OLAP component for cubes, and more recently, with SQL Server 2012, the tabular engine, the X-Velocity in-memory analytics engine for tabular models. The lesser-known cousin is the data mining engine. Now, when you install the multi-dimensional engine, you are also installing the data mining engine, but my experience will tell me with customers when I probe what they're doing with analysis services, almost never are they working with the data mining component, in part because they're not aware of it, in part because they wouldn't know how to work with it. It includes 9 algorithms, discovers patterns in data. That's what data mining is about. In fact, data mining is the wrong terminology. It really should be pattern mining. If we're gold mining, we're looking for specks of gold in masses of dirt. Pattern mining is looking for patterns in masses of data. So it's sort of a misnomer when you think about it, but the word and terminology data mining has stuck. With a focus then on one of the 9, we really could spend a session at minimum on each of them. This is a topic that I could have talked to you about 10 years ago. The Yukon project delivered the data mining, and we had the time series algorithm available then in Yukon project, and it was released in 2005. Now, what has changed is in the 2008 release, we still have the same algorithm by name, but there's actually 2 algorithms under the cover, the ART-XP and the ARIMA. And they work together to provide a more stable experience across shorter or longer term forecasts. So this is the algorithm, the single algorithm that you would turn to perform forecasting. So let's jump straight into a demo. Simple forecasting by using the table analysis tools with the Excel add-in. With Microsoft wanting to make BI available to the masses, now typically data mining is a data scientist's interest. And typically for good reason. They need to have good skills mathematically and with statistics to really drive and produce optimal results. At the other end of the spectrum, we have business users using Excel, this familiar, lovable tool. And so Microsoft have produced add-ins that enable data mining to take place within Excel itself. In fact, there are 2 add-ins. The table analysis tools, when you have a table, so I'm going to take this simple set of data being 12 months sales of 2 flavors of ice cream, and I'm going to make this into a table, and when I have this table, it introduces this Analyze tab on the ribbon. That is the table analysis tools. Providing you have a table, we can then mine this data. Now be aware that the data mining engine is not installed on the desktop. It does require that you have analysis services somewhere on the network. So as the DBA, I switch across Connect to Analysis Services. This is the multi-dimensional mode, which supports the data mining. Presently no databases, so I'm going to go ahead and create a database that will be called Session Mining. So this database is there like a play pit for the data mining activity that will take place by the Excel users. So simply as an empty database, I'm going to point out for those that are administrators, there's an important property that you must switch from the default, and that is the one here, which is to allow session mining models. A session solution is temporary. It's there for the existence of the session. When a disconnect happens, the resources are dropped. And that's precisely the way that the table analysis tools work. So now that I've got this database, we would have to educate the business users to connect. So I create a new connection across to the instance, select the session mining, and now we're good to perform some forecasting. And what I love about the options here is that the words data mining do not occur anywhere. There's none of this frightening technology interfering with the requirements that people have when it comes to working with data. So I simply need to forecast. And I'm going to forecast strawberry and chocolate. I'm looking for the next 6 steps in a series. And it just so happens I do have a month, which is my timestamp. And when it comes to this thing called periodicity, what business user is going to know what this means? But a look at the options here sort of demystifies it. Okay, I know that each row within this table is a month summary of sales. So I think monthly seems like an appropriate selection. We will talk about the importance of this shortly. Now, when the user clicks run, this is the communication. The data is being, in fact, structures are being created in the database, session structures. The data is being sent across the network to be stored. In being stored, it is being processed. The process results in the detection of patterns, and the request for 6 returns, first of all, 6 new rows to the table. And just to provide some context, I may copy down to learn that these are the future months in 2014. And here is simply a graphical representation of this. So what's happened in this simple activity is it's used history to detect a pattern and to apply that to predict future steps. Is this difficult? Are we going to trust entirely the result that comes back here and say that is absolutely what's going to happen? Please don't ever make those types of assumptions, all right? We don't ever know what's going to happen. Nobody does, all right? But the best that we can do is use what we know and also domain knowledge and maybe intuition to a degree to assess this, reject it, or maybe take the average of the two. This is what I thought it would be, this is what the data mining did, and it should be somewhere in between. But it's far better than flicking a coin in the air and guessing. I mentioned that the time series algorithm really is 2. So what we had, first of all, in 2005 was the ART-XP. This is the autoregressive tree with cross-series prediction. So I'll point out that Microsoft really pioneered this. Cross-prediction capabilities means that you could have multiple series of data, like chocolate, strawberry, vanilla, and you'd find that maybe the decrease in sales for chocolate actually results in the increase for strawberry, and it may well detect that between the series there's something to help it determine what future values on those series could be. So this is a really interesting thing that comes from Microsoft because there are no other cross-prediction algorithms that quite work like this. All right, so good examples, ice cream sales and temperature. You would probably expect that an increase in temperature would result in an increase of ice cream. All right, but you may have difficulty in actually understanding what would be the formula that I would use to estimate the production we should put in line, knowing the temperature is increasing. It's considered to be an accurate algorithm for short term. So what it uses, the autoregressive technique, is that it uses previous values. And what you've got to be very careful of is that before long, when you start asking for the 6th, 7th, 8th, 9th, it's using other predictions to support other predictions and simply amplifying any errors that it's already had. So typically, we would treat this for the next 1, 2, 3, 4 steps and be very, very careful in the interpretation of anything beyond that if it's using predictions for future predictions. Let's see this in demonstration by working with the second add-in that's available with the SQL Server add-ins for Excel. So having downloaded the add-ins, they are free, providing you have the right versions, editions of Office. When you install the add-ins, you get the analysis tools only when a table's in focus. The second add-in has its own dedicated tab on the ribbon. Now, this is really cool in the sense that it supports the entire life cycle of the data mining activity, from the important topic of data preparation, garbage in, garbage out. If you want quality patterns, you need quality data coming in. It then supports the modeling role. It supports the testing of accuracy. That is not something we'll focus on with this particular algorithm today. And then it supports the management and querying of the models, all within Excel. It's incredibly powerful. At your fingertips within this familiar tool. So I'm going to do a little bit of play here. Here for I'm going to come up with a cross-prediction scenario, just call it XP number 1. I'm going to keep this super, super simple, value, 0, and then I'm going to have an increment of 2 for each step. So if I copy this all the way down, I've got this series. If I select it, and then I perform forecast modeling on top of it, this experience allows me to pass in a range of data, a table, or even external data coming from registered data sources like SQL Server and so on. Keeping it very, very simple, let's see what we can configure here. There's no timestamp, there's the value, and then here in parameters. The algorithms have their own parameters that allow you to configure and tune their behavior. And there's this one here called forecast method that by default will mix ARIMA and ART-XP together. Because I'm demonstrating ART-XP with the cross prediction, I'm going to fix it to use this only. And that's configured the model definition. I need to provide it a structure name, and the structure has a model. So briefly, a structure is structure and data. And it's possible to have one or more models that reuse that metadata and data. Typically in data mining, you want to perform lots of different models with different parameters, different filtered sets, maybe different inputs. And then you go through this entire cycle of validating the accuracy and reliability of a model, and ultimately you'll select on one of those models to perform your exploration and prediction tasks. So keeping it very simple, one structure, one model. We're going to browse the model immediately and enable drill through. I'll just mention right now that's critical for time series. If you don't enable drill through, it can't store the metadata that's required to support the prediction. So you must always have drill through enabled. This is the result, as we'd expect, 2. And if I predict future steps, it just keeps moving. And what I can show you here is that the tree, the decision tree in the background, gives us the formula. See the value -1? Take the previous step, and that's where it's learned. Pretty easy. Just multiply the previous step or add 2 to the previous step. Okay, so I'm going to move to the next one, XP2. And there's a great function in Excel called the RAM between. Just give me some random number between 0 and 100. And let me copy and paste these as values, so they're now static. What do you think happens when you mine random numbers, like truly random numbers? Any takers? Okay, let's see what happens. XP2. So bouncing all over the shop. Let's take a look at this. And if I project into the future, I end up with this static line. And if I have a look at it, it's coming in at 54. And the equation that it came up for here was simply it equals 54. Being random says that there are no patterns. Okay, so that could be knowledge in its own right. The fact is this data, is there something in here? And maybe there just isn't. And after a while, you'll just give up with semi-satisfaction that, okay, there's just no pattern here. And that's the case. So I just like to leave you with that one. Here I'm going to move into a little bit more interesting data. Temperature and sales. This is a great one to become familiar with the cross-series prediction capabilities. So here I've got a set of data for month temperature sales for 12 months within a year. I'm going to go ahead and forecast it. This time I have a timestamp of month. I don't need to look for a pattern within it. And let's see what happens. Okay, so we see red as temperature. As it increases, we see the ice cream sales increasing as well. Now, the focus really here is just on the ice cream sales. And let's see, as we go to project future steps, it's a little bit lame, don't you think? If it met a peak in 1 year, why isn't it at least matching that peak? And the lesson here is a really important one, that when you know that there's seasonality or some recurring frequency happening, months within a year and the seasons that happen within a year, then you need to provide that as a hint. And there's an algorithm parameter called the periodicity hint. And you need to specify this, and I'll do that in the next task. Let's take a look at any formula that's developed. And it says, sure, the next step in a series is 33 plus add 14.2% of the previous point that you had. And that's how it's going to work. Do you see with this one with -1 that then the second prediction will be using the first prediction, and it will become unstable quite quickly? And to give you some visualization on top of that, if you show deviations, all right, when you get large deviations, the models become unstable and unreliable. And you can see here very, very quickly, it's blowing out and saying, don't use me. So let's move on to the next one here, which gives us 2 years of data, setting up very much the same thing, but let me apply that periodicity hint this time. So limit it here, ARTXP. And down here you have the periodicity hint. By default, it's 1, which says there really isn't a cycle. This is a set, 12. You could also do 12,3. There's also a cycle within the quarters of a year, if that made sense. This is a critical one that you get right if you know that there is some recurring cycle. And I think I'm up to XP 1, 2, 3, 4. And what we should find this time is, let's focus on sales. You see something that looks reasonably acceptable given what's happened in the past. And to take a look then at the node here, we see a formula that does use a cross-series prediction. It takes into account what temperature was at a certain point in time to derive what the future sales would be. Now, typically, if you're going to do time series, you want to have at least 3 cycles, okay, maybe 2. It's interesting to note that in data mining, you typically want reasonable volumes of data, but here's a big exception. The time series is very different. 36 rows of data for monthly data across 3 years could be reasonably good. So, last example, let's configure exactly the same thing, ARTXP, and the 12. What we discovered with this one is something really bad went on down here. Something abnormal has happened. And what does this end up doing for future projections? Yeah, not much. Something's really out here. And so here's an example where you might, skewing data, you might remove it. You might say something happened there. The manufacturing plant went down. That's what impacted on sales. It really should have been it. And sometimes as part of your preparation, you need to go and fudge things a little. Otherwise, it's going to produce this type of unreliable or simply not useful sort of result. What's interesting to note here on the model itself is nothing, actually. I thought I had something to say there, but I don't. That's the cross prediction. The second algorithm, ARIMA, introduced later. This came in the next release of SQL Server, the auto-regressive integrated moving averages industry standard algorithm. It's more interested in this moving average to provide a more stable, longer-term projection. Okay, so what Microsoft have done has given you a single algorithm that by default will blend the two together, giving you much more accurate short-term projections and much more stable longer-term projections. By default, it's giving you a 50-50 mix. So with a focus on a time series model definition, let's dig a little deeper. Your model must include a key column for time. Now, it doesn't have to be a date type. In fact, it doesn't even matter what the values are in there, but it just needs to be something. It typically will be numeric, but it could be dates. You then need predictable columns. They must contain continuous numeric values. When you define a model, your inputs are either input or input and predict at the same time. If you want cross-prediction, they must be input and predict at the same time. If you don't want cross-prediction between multiple series, then the inputs would just be predict only. Be aware that Standard Edition does not support this amazing feature of cross-series prediction. Now, it's important that you have cleansed credible data that makes sense and that you ensure it can be chronologically sequenced. The order in which it's loaded is critical because that is the time series across time. You're responsible for ensuring that it's ordered. There are two design approaches you might take here. The columnar format, as you see here, is that if we have multiple series, they're simply columns. The advantages are this is easy to produce. It allows specific column types. Google might have a different type to Microsoft. These are stock prices, by the way. A disadvantage would be that if you're going to introduce Apple into this, then you need to modify the structure by adding an entirely new column. The other approach is the interleaved, whereby you're simply pivoting. So the stock itself gets pivoted down into the series column. And the advantage of this is that the series names actually come from the data itself. It's easy to add new series in. The disadvantage is it could be more difficult to interpret and produce. And the continuous value here will have to use the same type across all series. But for stocks, that's obviously okay. The characteristics of the model then, that's the preparation of the data. There's some interesting things to point out here about a time series solution. I've already pointed out that it can be trained by using small sets of data. The training data, I've mentioned, must be loaded in chronologic order. You can effectively use cubes as a data source. Like typically, cubes aren't great for querying masses of data. And so for other types of data mining projects, querying a cube to bring back tens or hundreds of thousands of rows is simply not the way MTX was designed to work. It could probably do it, but it would struggle to do it. And yet this request for 36 rows of data coming from a cube is reasonably straightforward. The lifetime of the model is ephemeral. It may well just be that you create it, you forecast from it, destroy it. Because essentially it may become invalid when you reach the next time series point. And then you'll go ahead and create a whole new model with the new data that you have. So we have that ability to create session mining models, which in fact is the technique of the first add-in that I described. Models may require reprocessing as new time period data becomes available. I'm a little cautious there, may. You might actually create a model and say, that's it, that's the way ice cream gets sold. Regardless of what happens next month, we will use that for the next 12 months. We'll review it in 12 months and then produce the next model. So you might take either path. Let's reprocess every month or stick with it for the entire year. I've mentioned that the drill through must be configured. There's additional data that's being stored there to support prediction. And there's no such concept of accuracy testing. In other data mining problems, they're solved by taking your data, splitting it into a training set and a testing set, typically 70-30, train with the 70%, and then test the accuracy of prediction with the 30%. The problem for us is the set that we'd be testing from is in the future. All right, so we don't have that ability with this technique. When it comes to querying your model, there is the predict time series function. And essentially, you pass in the column or the predictable attribute of your model, and you specify how many steps in the series you want. There are many overloaded forms of this, so I'm not going to go through all of them. I'll point out that it returns a nested table that is a hierarchical row set, but we can flatten it. And that means the result coming back from this query is identical in structure to what you would have from like a SQL Server select statement. The beauty of this for developers is that when it comes to embedding data mining results, once you've got the query right, we'll talk about it in a minute, the result that comes back needs no different programmatic experience. It's just a tabular set. Do we display it somewhere? Do we load it to a table? So the integration story and the embedding story is very, very cool, in particular for .NET developers. Each row that comes back in this table represents a predicted step. So here's two different examples, depending on whether you're using the columnar format, where you have your series as columns, or the interleaved. Predict time series, give me the next 3 for the Microsoft. Or the interleaved is where we would use a where clause. Filter, just give me where it's Microsoft and give me the next 3. Additional scenarios, interestingly enough, -6 to 0. You can request, let's just say I have 24 points on my time series, and I'm going to ask it to start predicting from the 18-month mark. Now, it's interesting to note that the patterns have been stored based on the 24 months, but you could then go and say, but according to the 18 months, what would the next be according to those patterns? Possible. A prediction join in data mining allows you to integrate data with the model. So there's an interesting couple of scenarios here for time series. This was introduced in 2008 and only available with the Business Intelligence and Enterprise editions, replace model cases. So I've got 24 cases representing 24 months of sales. I want you to replace the last 6. Now, it's important to note, again, it does not change the pattern, but it does then influence the future predictions because you're adjusting what perhaps the last 6 months were. The extend cases allow you to say, well, actually know what is happening. So go and extend, and it will use those, and then it will start prediction beyond the extended cases that you give it. So it's interesting for a what-if scenario that if this were to happen, where would we end up? Querying a mining model by using Excel. Switching back to Excel, let me just point out here on the trace, all of those activities have been traced here, the commands that were sent to the server to create the models. And if I go to Browse, they're all here, structures with single models within them. So what's cool is that you can query and bring the results, these prediction results, into your Excel workbook. So let me just choose, for example, XP3, and I'll say, give me the next 6 points of sales or temperature. Or the advanced is pretty cool because this allows you to create perhaps more complex structures, and there are templates here to guide you. And I can just come in here and say it's actually sales and build up the DMX query and request the next 12 points. And there's a valid DMX statement for the forecast. Let's load that to a new worksheet. Voila. What we get are the values representing sales, and importantly, to understand with confidence how reliable those values could be, a standard deviation. And this would allow us to understand with our probability where it fits. We'll come to this topic in just a moment. So again, see how simple it is, or relatively simple, for an Excel user, and perhaps a more advanced user, to be able to connect to, query, consume, and think of the Power BI tool set. Well, it wasn't developed with this in mind. This is a beautiful way of getting data and starting to integrate it, loading into Power Pivot models, and building in forecasting and prediction capabilities to your solutions. Tuning a time series data mining model. So additional data mining functions can be used to determine the quality of a prediction. From a statistics point of view, we really look at variance and then standard deviation being the square root of variance. So here's an example of a query, and in fact this is identical in structure to the one that I just built with the template, that queries also for the standard deviation, and that would allow me then, with my knowledge of normal distribution, to go, well, for that month, how confident am I? And if I wanted a confidence of 68%, then I would take the value and I'd allow plus or minus a single standard deviation. And if I was happy to 95%, so I could come back to Excel here and say, well, look, just how confident am I about this? I'm not exactly sure why these values are loaded as text. You do need to come in here and convert them to numbers. But if I just put lower range and upper range here, and I just said, go ahead and round my value minus 2 multiplied by the standard deviation to 0 decimal places, the lower limit would be this. And if I copied this to the next cell, change the minus to a plus, what I have are the upper and lower ranges. Okay, so certainly at this type of standard deviation, you're not ever going to be trusting this, and the results are nonsensical as it is. But what you're aiming for here is for the smaller standard deviations that should instill a sense of trust in what the model's delivering to you. High deviations may be addressed by tuning the mining model by configuring algorithm parameters. So now's a time to take a look at what the time series algorithm offers to you in the form of levers, knobs, and dials. Be aware that if you're on standard editions, some of these are locked in. That's just part of the feature set or the lack of features. If you want the more advanced features to configure and tune mining models, you'll need Business Intelligence or Enterprise Edition. There will be no difference between the two of them. Business Intelligence Edition will give you every capability. So missing value substitution. It's critical with the data that you pass in that there are no missing points. You should not pass in null. Typically, in a preparation phase, you would detect these and maybe even use other data mining techniques or simple statistics like just take the average of the other sides, the previous month and the next month. That's the best that we can do. The good news is that you may not need to do this, that you can configure a parameter that says if there's a missing value, use the previous or the mean between either side. I've covered the periodicity hint. And this is super, super critical where you do know that there's a cycles. It will make a significant difference. It will know deliberately where to look for patterns and repetition of patterns. And so this is where you'd specify for monthly data 12. The easiest way to remember this is how many rows before the cycle starts again. 12 months before we're the next year, it's 12. And it is possible to have other cycles within there. 12,3, we're also expecting that there's a 3-monthly cycle. Very, very sensitive to this parameter. The forecast method, available only with the Business Intelligence and Enterprise Edition, allows you, as I've demonstrated, to control which algorithm it uses. By default, it's mixed, but you may specify exclusively ART-XP or the ARIMA. The prediction smoothing allows you to control the mix. So it only comes into effect if you're in the mixed mode, and then you can specify a weighting. Is it 20% ART-XP and 80% ARIMA? And it sort of results in this type of thinking, that if it's 50%, it's 50%, but as the future steps come in, the ART-XP fades out and the ARIMA fades in. So you can control what you're looking for, more stable long-term prediction or more accurate shorter-term prediction. Instability sensitivity. What you might find is that the algorithm will detect when it's just way out, and it will just stop to give predictions. And you can override this and say, I don't care, just give it to me anyway. You'd have to turn this on. Or control it to a degree between 0 and 1. Closer to 0 will reduce the impact of the detection of instability. Next, minimum and maximum. You can constrain the maximum prediction or the minimum predictions that the model could make. Doesn't make sense to sell negative sales volumes. So, are there any questions at this stage? It's a lot of theory to dump onto you. What I've got next is a couple of demonstrations at end-to-end, and I'm choosing to use different tools this time. Now, as the IT professional, I'm going to move away from Excel as the environment and use Visual Studio with its project templates to produce the solution. And then I'm going to work as a DBA using script to produce a solution. Now, before I do, my data that I'm working with is in Excel, so that is the source of it. And here I have, up until yesterday, all of the stock prices for 5 major IT organizations. My theory here is that there could be some influence that if Google goes up, maybe Microsoft goes down. I can test this hypothesis by training a model and looking at the equations that are produced for each series. Now, this would give me the columnar format, but I'm going to work with the interleaved format. Good news is I've got a great tool called Power Query. So if I can make this into a table, I can use Power Query to base a query off that table, and then I can come in here and simply multi-select those series and unpivot. And this will become my stock. And then this will become the price. So don't overlook the newer tools in assisting the older techniques. Okay, and I'm going to switch across and open up a script to create a relational database that will store this result. Open file. And so I have my stock forecasting. And so what I'm going to do is create an entirely new database called demo. And within this database, I'm going to create a table that has a date, stock, and price column. I love this technique. You just come into here, and I'm going to create an insert statement for each row. I wish there was a technique that Power Query would load data into a SQL Server table, but there is no such thing. If I create a custom column that I'll just name SQL, and I have a snippet down here that is simply concatenating the appropriate values to build a valid insert statement. So I paste this in. What I get then is an insert statement for each row. And I'm going to load this to the worksheet and apply that query. And then I simply select the very first one, Control-Shift-End, and there's 1,260 rows here representing every business day or NASDAQ operational day for 5 stocks. Then I can switch across to here, new query, paste the lot in, execute to load that data in, and then just to confirm that it's there, there is our carefully prepared training data, interleaved. So now I open up Visual Studio and I go ahead and create a solution with a project which is the Analysis Services, multi-dimensional, and you can't fully read it till I expand, and the data mining project. This has not changed in concept since 2005 when it was first made available to us. This will become my stock forecasting project. And then this will become my demo solution. All right, let's define a data source to connect to that carefully prepared training data that lives on the local host of SQL Server in a database named demo. Next, I need to create a data source view and simply bring in that single table. And this is like a virtual schema upon which the mining structure we created, stock forecasting. All right, there's all of the data. Next, a mining structure. Remember, a structure is a container for multiple models. It allows the reuse of metadata and data based on the time series algorithm. And the data source view I've just created has a single table, stock price, and the key columns are both date and stock. And what I'm looking to do is predict price, and for cross-prediction, it's an input as well. If you don't specify that, there's no cross-series prediction taking place. Next. Data types are fine. If it comes from SQL Server, there'll be no configuration required here. This will become my stock forecasting structure with a stock forecasting model name. Structure is created. The second tab here shows me a single model for the structure, and a right-click algorithm parameters allows me then to tune. Let's leave it as mixed. Let's put in that we know, is there a periodicity? Is there a hint that we need to provide here for stock daily market close values? I'd argue not. We don't expect that there's an annual seasonal cycle with this, so we're going to have to leave it as 1. So there's no configuration that I'll take here, and then I right-click deploy. That results in a script being sent to the server, creates a database structure model. The default processing option takes the training data, and the engine is detecting patterns and loading them. Happens reasonably quickly. And then switching across to the next tab, we get to see this visualization, the very same visualization that you can launch from within Excel. And in fact, you can embed into your own .NET applications as a way of distributing exploration of models within the organization. You'll see those inner leaves come up here. I'm just interested in what's going on with, let's say, Microsoft. And here we can start performing predictions. We can then take a look at the model here and learn that Microsoft has an equation here that it takes Google from 8 steps ago. It found some type of relationship that if Google moved, then it will impact somehow negatively or positively the Microsoft price. Now, this is not the best example. I mean, what logic goes into stock prices? You wouldn't know. It would take a politician saying something silly to rock the stock market. You could never factor this into a model. But it does help you understand to some degree maybe correlations that, a rise in one results in a rise or a decline in another. So just be very, very careful in the way that you interpret what's given here. And I'm not suggesting this is an appropriate thing to do. It may be just a little fun for this demo. What about Facebook? Facebook's only ever dependent on itself, so it takes in past steps to factor what future steps would be. The last tab then is the prediction tab. And then I could come in here and say, well, give me stock, and then bring in a prediction function, which is that predict time series. And let's predict the price. And I would like to predict the next 5 steps, comma 5. All right, and then when this is run, there is a nested table for the 5 steps for each of the stocks. Now, what you typically do if you're going to consume this by a reporting application is use the flattened keyword. And that would flatten the entire set. And if you do need to filter it down to a single, that's where a where clause comes in. So DMX is data mining extensions, not expressions. It's extensions of T-SQL. So if you're a T-SQL developer, you're 90% a DMX developer. You just need to learn the concept of a prediction join and the prediction functions. So what we've got here is simply a where clause, and yes, there's an order clause as well, where stock is equal to MSFT. And rerunning this with the correct syntax, single quotes. Let me copy that to the clipboard. Results in this. There's the prediction and something that you could query. Integration services could load it. This could be loaded into a Power Pivot data model, and away you go. Next. The next example I'm going to achieve with script. So what I have here is some monthly summary data, or really the sales stock price from Microsoft at the end of each month, and some other statistic that comes from the Bureau or the US Census on trade report retail data. These are industry sales for the IT sector. Is there some correlation between what people are spending and the stock price? Well, let's discover. So what I'm going to do in this case to speed things up is just unhide this column, and there is a select statement waiting, or an insert statement waiting for me. So a different script here is going to create a new table for this data. And I have this here. I'm going to create a table just called MSFT data with a month, the stock price, and the industry sales. And then I simply copy all of those insert statements to load that data in. Now, note down here, we don't have information yet. The Bureau hasn't got up. All right, so I'm going to insert null. And that's illegal. You must have a data point. Let's see what happens. So I insert this data, and then we just return to see that that's loaded into this table. So the technique that I'll use this time is script. A DMX script here, and so I'm connecting to the stock forecasting database. I use this command to create a persistent mining structure. So it basically consists of the columns or the attributes, their data types, their roles, and content type. And then I alter that structure by adding a new mining model, and these are the predictions. The month is our time key. It uses this algorithm, and this is how we pass in the algorithm parameters. So there's the monthly hint. And then it's the insert command. Who would guess? When you insert data into a structure, it processes all models that begin to the structure. So notice here the open query technique. This demo, by the way, if I connect to the deployed database that I developed, it's this data source here that I'm referencing when I execute this query. Go and load the result of this query from my MSFT data table. Note the order by month, critical that it's loaded in chronologic order, and then I load this data in. And then it says, error, and I expect this because you can't have missing values. And so this is where I drop the model, and I redefine it this time by saying the missing value substitution is to use the previous. Having executed this, I reload data in, and we should have success. You can query the model for the cases. The cases are the rows of data that have been loaded in. It says, no, you can't do this because drill through wasn't configured, and this is a requirement. So again, let's go back and drop the model, redefine the model this time by using the with drill through. And now let's query for those cases. Still hasn't been processed. Still hasn't been processed. And I intended that. You've got to insert data in. That is the process command using DMX. Now that it's been processed, we can query the cases, we can even query the content. What I'm querying here are those patterns that have been stored in the model. And because this is a mixed algorithm, we see some ARIMA content. We see two nodes here that is the ART-XP, and here in a nested table is the formula, the regression formula for computing the future steps. Lastly, to perform a prediction from this, there's the select flattened predict time series, and there are the 12 future steps that we could have. Okay, so what I'm going to do is move to the next demonstration by copying this back into a worksheet. There are the next 12 months that we're predicting. And if I come back to the Microsoft data here, I'm going to insert a column, and I'm going to label this the MSFT forecast. And then I'm going to take that copy and paste it in, because typically what you want to do in a reporting tool is plot what happened and what we plan to happen. And just by copying these down, I get the time series values. So what can now happen is I can select this as a range representing two series, being the actual and our forecast. Let me go ahead and make this into a table, and I'm going to name this table Report Data. And then I'm going to go ahead and insert a Power View sheet. So that table that is loaded to the workbook data model, Power View sheet is added, and it's going to add that data into the sheet for me to start visualizing. All right, tabular view, least interesting way to represent a time series. More interesting is to just simply use a line. Because there's two series here. We see Microsoft and then the Microsoft forecast. Here it is. You might wonder why there's that gap. And the reason there's that gap is because there's a jump from here to here. So what I would typically do is take this value here, the forecast, and paste it into here. And I'm guessing if we come back here and refresh, no. There we go. Had to reload it to the model, then it queries on it. So here is the view that we could then express based on what happened and what's going to happen. And then what I'm going to do is add a second, which will be simply a single series of what happened for Microsoft. So this is the report data, just bring in by date, by Microsoft, and let's use a single series here on the line. Voila, I'm done. I'm going to publish this to a Power BI site. Do you remember the keynote on Wednesday? And one of the most amazing things that I saw, and that was the new forecasting capability in Excel Online. Let's see how it works. Let's do a comparison about what Analysis Services on premises is predicting and what this new Power BI component is predicting. So the preparation I'll do will be to only publish select sheets, and that would be my sheet that is, I don't know because I didn't rename it. This will be my comparison. File, browser view options, particular sheets, nothing except the comparison. Where are you? And now I save this, switch across to my Power BI site, add this workbook. And let's see what this new feature tells us. As I discovered this morning when I used this for the very, very first time, it's not a Silverlight capability. It's, in fact, HTML5. So that's the first lesson, is that when you have this, you'll need to use the bottom right corner to switch this to an HTML5 representation. The next thing I learned was it must be a single series line. So the first one that includes a series of Microsoft history and Microsoft forecast is 2 series that will not work. And now what happens is that when you use the analysis here and click, I can start to project. And let's bring it up to the next 12 months. Okay, so we've got Jan 2005, there's Jan 2005. Do you see any similarities? Hold on, stop. I'm not touching anything. That's a shame, because I really wanted to point out that there's actually not much in common between them. That's obviously a beta bug of some sort. That's a shame. I'm tempted to do just a reload and see if I can try that again. I have not achieved an infinite forecast. So technique again, in case you missed it, HTML5, selecting here, and let me just be a little more careful about what I do here. Okay, watch it quickly. Is there a similarity? No. So what we're seeing here is 2 different statistical techniques, mining techniques. I don't know what it's doing. And I think this reinforces the point that no one really knows the future, but we can do the best we can with the history we have and the techniques that we have with data and so on. Take a look at the parameters that are exposed here. Your periodicity is called more user-friendly seasonality. And here is the ability to display those boundaries of 95% or 68% confidence. Okay, so that's the new feature, and I think it's interesting to see we've now got different techniques. What I would say about this, however, is it's very different to what I've been showing you, because this is not a persistent experience. You don't actually get a data set coming back that you can do something with. So it's an interesting way to look at your data, interact with it in a web browser, but it's not a substitute for the techniques and all of the knowledge that I've been transferring for you so far in this session. Okay, I'm going to kill this because it's probably going to kill my browser. Additional concepts to round this off. Business scenarios. So consider any scenario involving the need to know what's likely to happen across time. What could happen? From a planning point of view, you could use forecasting to seed future planning values. I'm not suggesting they will become the final values, but it's a starting point. If that's what's happened in the past with our actuals, let's use that as a projection, and then let's use domain knowledge and reality to massage that into something that's acceptable. We can embed forecasts into applications. So data mining visualizations, in fact, the same visualization that I've been showing you, launched from Excel, embedded into the Visual Studio project, also launchable from Management Studio, can be embedded into .NET applications and distributed royalties-free. You will require connectivity and permission to analysis services, so it's not entirely free, but it's a very, very easy way to distribute and allow discovery of data mining out to your business user community. You can also embed into applications. The SQL CLR is another interesting story. So you could query SQL Server objects that in turn programmatically are perhaps creating session mining models on the fly, passing data in, and outputting results for T-SQL queries to be consumed in line. So be very, very creative. What I haven't had the opportunity to show you in this hour, beyond the add-ins in Excel, beyond using a Visual Studio project, using script with DMX, is that you can use ADOMD, and there are object libraries for creating and maintaining data mining solutions that .NET developers would pick up reasonably straightforward. So for the IT professionals, some ideas could include mining server performance to gauge when hardware upgrades may be required, keeping track of disk consumption, and in particular with a cross-series prediction, it might be in response to sales volume or new customers. You might find some interesting correlation that will project based on what marketing think is going to happen. This is the disk space that we're likely to need at this point in time. And that's going to make it easier for you to justify capital expenditure rather than saying, my gut instinct or my pet octopus over here is suggesting that it's going to be November next year. Here's some hard numbers that's going to back this up with a degree of confidence statistically. So, in summary, the Microsoft time series algorithm is used for forecasting. Choose a tool that fits your skills and requirements, whether it's entry-level, business user, information worker with the add-ins in Excel, whether it's someone that is more skilled perhaps a business analyst, data scientist. They could use SQL Server data tools with the project, or they could go straight to script, and there are people that actually prefer that. The scripts are easy for them to understand, to adapt, and to replay. The developers could go for .NET programming option. Algorithm parameters can be configured to tune the mining model, so we'd suggest you explore and play. Trial and error is the key to this. Remember, you're never going to reach perfection, but your ideal is to tune it to give you the most satisfying, reliable response. Developers can easily embed forecaster predictions into applications. That's the big takeaway. It's not necessarily a standalone, there's the result. Embed it and integrate it into other experiences to create a new class of intelligent application. So, on that note, leave the octopus where he is and enjoy the taste of octopus rather than using the octopus for prediction purposes. And I have to add, I just think octopuses are amazingly intelligent animals, and I think the concept of encouraging you to go out there and eat them may not be the responsible thing to do. Are there any questions in the final 33 seconds I have? Is there one or two? If not, it's a little impractical in this size room. I would encourage you to come see me up front. I'd be happy to talk to you more. From a resources point of view, Microsoft have their predictive analytics site. There's also comprehensive documentation about data mining, including documentation on techniques and the functions. The SQL Server datamining.com is a site that has been maintained by the data mining team. It includes resources like samples, tutorials, webcasts. Great place to check out resources on what could take you to your next steps in your data mining projects. Implementing smart reports. I found this one recently. Here is a code example that you could work from to create SQL CLR tables or store procedures that will use data mining under the covers to easily integrate prediction results back into the relational world. This is perhaps the only publication you would consider. It's reasonably comprehensive, introduces you very nicely to what data mining is, dedicates a chapter to each of the major algorithms, and then starts to talk about integration with the rest of the SQL Server stack and how developers can embed them into application experiences. Interested to know more about that octopus? I've included the link on him also. So we'll remind you, we very much appreciate your feedback. It's important for us to understand how we've met your requirements. We'd ask you to take the time to connect and provide your feedback on this session. Beyond that, thank you very much for your time and attendance, and I wish you all the best with your forecasting experiences. Thank you.